Oh, okay. Day. I don't even remember what day it is now. Let's try and do a LeetCode, I guess. Let's do jump game today. You are given an integer array nums. You are positioned at the array's first index, and each element in the array represents your maximum jump length at the position. Return true if you can reach the last index, or false otherwise. Okay, so it represents the maximum. Let's see. So that's basically almost the same thing as saying is it a solver? Okay, so I guess maybe let's start off with an even simpler case. So 2, 0, 4, like this. 1, 0, 4. So 1, 0, 4 in this case, it's never possible to actually reach the last number. But then if it's 2, 0, 4, it becomes suddenly possible. Okay, so I can just do max range equals to 0 for I in range then nums minus 1. We can, because every time we add on a step we need a minus, so we can do current max is equal to nums I minus plus max range minus 1. And then we do if current max is greater than, so we can just do length equals to len nums for length minus 1, because it doesn't really matter the last index anyway, since you never, you meant to reach the last index. So if the current maximum is greater than the, or equal to the length, we can return true immediately. Otherwise, if current max is greater than max range, we can do max range equals to current max. And then in the end, we can just do return current max is greater than or equal to length true, otherwise false. Does Python have a ternary operator? Oh. True if else false. Damn it. Expected true, return false. So, okay, what went wrong here? So for I in range length minus 1, so length is so the current max is equal to nums I plus max range minus 1. Okay, so I need to do this. And then, yeah, okay, and then we do if length equals to 1, we can just return true immediately. Okay, and then the max range will just be num 0 at first. And then we can just do max range is equal to nums I, so 0 plus 2 minus 1, which is 1. Equals to 1. Current so max or the maximum you can reach from the current, or the maximum number of steps you can reach from the current. So if current max, so this is index 1, so I plus 1, because I plus 1 represents the current position it's on. Else, if the current maximum, so if the range you can reach is greater than the max range from the start, otherwise it isn't. So in this case over here, let's do it. So it starts off at 2. Max range over here is going to be 2 plus 3 minus 1, which is going to be 4, which basically means you can reach, which basically means you can reach index 5 from the first index. So you can jump 4 indexes, pretty much. Now if the current max plus I, so that's going to be, so I plus 1 just represents the actual value number. So if 5 is greater than or equal to the length, which is 5, return true. Otherwise, if the current maximum, which is going to be, so that was going to be 5, 4, which is 4. So current max is 4 plus 2, 6. Yeah, 4 is greater than the original max range. Okay, no, so current max just represents how far you can move from the, or how many more extra steps you can move from the current index, which means that should be doing that. What? It's flipped now. Okay, so why is this not the case? So this is going to be max range is 3. Max range is going to be 3. And then for range equals to 1, so max equals to 3, or 2 plus 3, so 5 minus 4. This represents the maximum reach from the first index. No, so I can just do if current max to current reach. So current reach. I guess it's just me. No. This is very similar to the stock one. Why can I not do it? It's just basically current reach equals the nums I plus max range minus 1, because you increased an iteration, so you need a minus 1 from the reach. I guess. Maybe no. That's not even how it works, right? No, so nums see who is bigger. And then we do nums Oh, I know I can do this one. Why am I just being fucking stupid? So the current farthest index is going to be nums I plus 1 because it's one index. And then we do if there we go. What? Search for the farthest index that can be. So my algorithm has problems then. Okay, so if farthest index is greater than and I plus 1 is less than or equal to max index, meaning that I can actually reach it in the first place. What? So the max index you can reach is just the first one. Current farthest index would just be the current one. Yeah. If the current one is greater than or equal to the length, then we return true. If the current farthest index is greater than the max index specifically, which it is because this one we can reach for, and we need this I plus 1 to actually be reachable from the start, and I plus 1, which is 2, is less than or equal to the max index, which is 1. Otherwise, we don't do that. And we go to the next iteration, and we drop out. What? What is the max index in this? Oh, I guess maybe it's just this part here that was causing issues. Okay, so we'll just get rid of this. Much better. Yeah, okay, finally. Jeez. Why? am I so stupid? This is like the exact same as the gold one, isn't it? How fast is this one? I had the same idea. Why am I just implementing it in such a complicated way? 3 millis. This is so much faster than whatever the fuck I did. Okay, cool. Just ended that one.